Hello everyone. In this video, I will explain how to solve non-homogeneous system of linear equations in two variables and in three variables in just 2 to 3 steps. I will explain the method followed by I will explain a few previous JEE main questions. So here consider a system of non-homogeneous linear equations in two unknowns, x and y, which means that we are taking two straight lines. One is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. So together is known as a system of linear equations where c1 and c2 are not at a time 0. If they are at a time 0, they will have always a solution, which means that they will have a solution 0, 0, because both are passing through origin. When C1 is 0 and C2 is 0. So that's why here both C1 and C2 are not at a time 0. Now, we know that two straight lines always either they will intersect at one point or they will intersect at no point or they may intersect at infinite number of points. So when will two straight lines intersect at a point? When the slopes are not equal. When the slopes are not equal. So if slopes of two straight lines are not equal, then definitely they will intersect. Here slopes, my meaning is finite slopes. So here you see, this system will have a unique solution. This is the system. This is the system. Will have a unique solution if slopes are not equal. So here, if slopes are not equal, m1 not equal to m2. So which means that what is the slope of the first equation? Minus a1 by b1 not equal to minus a2 by b2. This we can write. This is we can write simply a1 by a2 not equal to b1 by b2. So solving system of linear equations are very, very important, particularly in two variable and three variables also. We have so many questions. You can find a question in JEE Advanced 2016. So this system of equations in two variables will have a unique solution. Unique solution means one solution. When a1 by a2 means ratio of coefficients of x is not equal to ratio of coefficients of y. Simple. Which means that the lines will intersect at a point. So the meaning of this one is the lines will intersect at a point. Only one solution. Now, they will have an infinite number of solutions. They will have infinite number of solutions. Means the lines must be coincident. The lines must be coincident means both equations represent a single equation. Given two equations will represent a single equation. So if here a1 by a2 equal to b1 by b2 equal to c1 by c2. Remember, a single equation in two variables or three variables or four variables, any number of variables, will always have an infinite number of solutions. So if the given two equations represent a single equation, then they will have infinite number of solutions. So here lines are coincident. Lines are coincident. Third one is the system will have no solution. System will have no solutions means if the lines are parallel. If the lines are parallel. So which means that slopes must be equal. So if slopes must be equal, so M1 equal to M2, but not identical, but not identical. If they are identical, for identical lines also, actually slopes are equal. So that is, or you can say A1 by A2, right, equal to B1 by B2, but not equal to C1 by C2. So here lines are parallel. Then system of equations will have no solution like this. Lines are parallel. This is one line, this is another line. So this particular simple concept can be solved without matrices. Without matrices, I'll give you a simple example for this to understand infinite number of solutions, unique solution, and no solution. So here is a question asked in JEE Main 2022. See, they have given a system of linear equations in two unknowns, x and y. They have, the system has infinitely many solutions, asking what is the value of modulus of 9 alpha plus 3 beta plus 5 gamma, right? So for infinitely many solutions, here you see A1 by A2 equal to B1 by B2 equal to C1 by C2. So only one line. So here is solution. For infinitely many solutions, A1 by A2. So which means that here 2 by alpha equal to B1 by B2 equal to minus 3 by 5 equal to gamma plus 5 by beta plus 1. For infinitely many solutions, the lines must be coincident. So both equations represent one equation only. For that, ratio of x coefficient equal to ratio of y coefficient equal to constant. So now you see, taking first two, you will get that here you see 3 alpha equal to minus 10. Okay. And taking last two equations and minus 3 beta minus 3 equal to 5 gamma plus 25. Okay. So which means that this implies they are asking, you see the expression 9 alpha plus 3 beta plus 5 gamma. Same you are getting here. 5 gamma. This implies 9 alpha I want. So this is minus 30. And bringing this minus 3 beta this side. So 3 beta plus 5 gamma equal to, you will get minus 28. So now adding these two equations, this implies that modulus of 9 alpha plus 3 beta plus 5 gamma equal to, you will have 58 for infinitely many solutions. If you want a unique solution, right? So I'll solve this equation further like this. For unique solution, here I'm writing. For unique solution means the same equation can be solved for different categories. For unique solution, that slopes are not equal. For unique solution, 2 by alpha is not equal to minus 3 by 5. This implies that alpha is not equal to minus 10 by 3. irrespective of the values of gamma and beta. So here beta and gamma can take any real number. So they are belongs to R. And for no solution, for no solution, you see that 2 by alpha equal to minus 3 by 5 and not equal to gamma plus 5 by beta plus 1. This is the case. So which means that here alpha equal to, for no solution, they are parallel but not identical. So this implies that alpha equal to minus 10 by 3 and solving these two, you see, this is the condition. So when you are equating these two, you will get this, and 3 beta plus 5 gamma not equal to minus 28. So whatever values of beta and gamma satisfying this equation and alpha equal to minus 10 by 3, then the system will have no solution. Now coming to a system of non-homogeneous linear equations in three unknowns. A system of non-homogeneous linear equations in three unknowns x, y, z. So here I have taken three equations, or you can write in matrix form that you see a1x plus b1y plus c1z equal to b1. So this is the matrix representation of this system of non-homogeneous linear equations. Here, that right-hand side D1, D2, D3, they are not all at a time 0. If they become all 0, then it becomes homogeneous system of linear equations. Now here, each equation represents a plane. Each equation represents a plane. So we are solving that a system of three planes. Means system of three planes will have unique solution, will have infinite solutions, or will have no solution. Means all the three planes may meet at a single point. Like you can think three walls in your room which have a common corner, right? Or you can think that all the three planes meet along a line. All the three planes meet along a line means you consider 3 pages in a book. So they have commonly infinitely many solutions. Or three planes will not have any solution. Three planes will not have any solutions means they all may be parallel, or two may be coincident but parallel to the third plane. There are several cases. So here, how do we solve this system of non-homogeneous linear equations in three unknowns? Just in two steps. Just in two steps. So here, so to solve this, we have to write an augmented matrix. We have to write an augmented matrix. So here is the augmented matrix. Augmented matrix means combinedly writing that coefficient matrix A, this is A, and that constant matrix B. And this is a variable. So that system of linear equation can be written as simply Ax equal to B. So here I have written that A and B together in a single matrix, that is an augmented matrix. Now we assume that A1 is not equal to 0, means coefficient of X is not equal to 0. So you first try to write the first row of elements must be in such a way that coefficient of X is not equal to 0. If it is in first equation, you write the first equation. Suppose first equation, if they have given coefficient of x equal to 0, then you choose second equation or you choose third equation. Better you write that first row elements that they must be small comparatively remaining equation coefficients. So here you see what is our strategy. The first step after writing that augmented matrix, the first step is see using this first element, this one, we make the remaining two elements in the first column as zeros, right? So using some row transformation, So this is equivalent to here A1. In exam, you need not be write the first row elements and you need not to write these separated dots, not necessary. So using some row transformations, we have to make that A2 as 0. So this is 0. So what we have to do is, here you see that R2 implies you multiply that second row elements by A1, which means that A1 into R2 minus A2 multiply A2 to the elements of first row. So A2 into R1. That's it. So this first element becomes 0 and remaining elements I do not calculate, just I am writing in variables like this, D2 dash. Whereas third row operation is R3 implies, right? So multiply third row elements by A1. So A1 into R3 minus first row elements by A3. A3 into R1. Now you will get here, this is 0. This is B3 dash. This is C3 dash. And this is D3 dash. Step 1 is over. Now, what is step 2? Right? So using that second row, second column element. So using this element, we must make this as a 0. So this is again equivalent to, don't write exactly equal because these matrices are not at all equal, right? One matrix is obtained from the other by applying row transformations. So this is equivalent to, once again I am telling, when you are solving this system of equations in examination, you need not to write first row elements in the second step. Wastage of time. So here you write this A1, B1, C1. This is C1, B1. Now write second row element B2 dash, C2 dash, and D2 dash. Now we have to make that this element 0 using B2 dash. So what we have to do is multiply second row elements R3 implies just multiply in reverse. So here R3 implies B2 dash into R3 minus B3 dash into R1. This is just to explain the core concept. I am writing this. So later on you can understand when I solve a few examples. Now you see this becomes 0. This is 0. C3 double dash and this is D3 double dash. So again, this is nothing but a system of linear equations. Now, coming to the core point. So after reducing into the third step, here assume that B2 dash is not equal to 0, this element. Suppose if this is 0 and in third row, second column element, in third row, second column, this element is not equal to 0, then interchange the rows. Okay. So now you see. Now, after reducing into this system, it is equivalent to system of linear equations. This is the first one is the first row, first equation. Second one is the second equation. The third row represents a third equation. Now you see, it will have the system Ax equal to B will have a unique solution. Unique solution means only one solution. All the three planes meet at a single point, right? For that, we must get x, y, z finite values. See here, z equal to d3 double dash by c3 double dash. So c3 double dash not equal to 0. So for to have a unique solution, we must have that C3 double dash is not equal to 0. If C3 double dash is not equal to 0. This one. Which means that determinant of A is not equal to 0. So in any system of linear equations, if determinant of coefficient matrix is not equal to 0, then the system will have a unique solution. Right. So here the simple concept is after reducing into this format, this is the row reduction. Only one step that C3 double dash is not equal to 0, then it will have a unique solution. For an infinite number of solutions, means all the planes meet along a line. Right. For that, what is the condition? If that C3 double dash equal to D3 double dash equal to 0. Means last row elements are all zeros for infinite solutions. After reducing into this format, all elements in the last row must be 0. Then the system will have infinite solutions because 3 system of linear equations reduced into 2 system of linear equations. So 2 system of linear equations in 3 unknowns means they represent 2 planes. So always 2 planes, either they meet along a line or they are parallel. Parallel means no solution. Parallel means no solution. Or they are coincident. It means that they have infinite solutions. So here I have taken that B2 dash is not equal to 0. So for infinite solutions, that C3 double dash equal to D3 double dash equal to 0. Now for no solution, C3 double dash equal to 0, C3 double dash equal to 0 and D3 double dash not equal to 0. Which means that if you see C3 double dash equal to 0 means here x into 0 plus y into 0 plus z into 0 equal to D3 double dash not equal to 0 is not possible. That's why no solution at all. So if you can remember these 3 concepts, that you can solve plenty of questions very fast, just in 2 minutes. Each question can be solved in just 2 minutes. Now from second and third, what we can conclude that if det A equal to 0, determinant of coefficient matrix equal to 0, then Ax equal to B, the system Ax equal to B will have either no solution or will have infinite solutions. Either no solution or infinite solutions. solutions. You see, in both the cases, C3 double dash equal to 0. In both the cases, C3 double dash equal to 0. So C3 double dash equal to 0 means, you see, this is the matrix A. So when C3 double dash is 0, which means that third row becomes 0. So determinant becomes 0. So when det A not equal to 0, the system will have unique solution. If det A equal to 0, either system will have infinite number of solutions or no solution at all. For no solution, after reducing three equations into two equations, for no solution, the planes must be parallel. If planes are not parallel, then they will have a infinite solutions. Now I'll solve a few questions exactly based on this concept. Here is the first question asked in January 2023. If the system of equations, it is a non-homogeneous system of equations, has infinitely many solutions, then what is the ordered pair lambda and mu? Okay, see how you will solve. Now, first you write that augmented matrix, means you write all the elements in the given equations. So I have written here is 1, 2, 3, 3 in this way, right? Now, what we have to do is using the first element, we have to make that next two elements as 0. So this we have to make zeros. Okay, so here what we have to do is R2 implies R2 minus multiply first row elements by 4 R1. So you write first row elements as it is 1, 2, 3, 3. Now you see multiply first row elements by 4 and subtract from the second row. Only subtraction of numbers. So here you see 0. Here you are multiplying by 4. First row elements multiplying by 4. So 4 to 8, 3 minus 8 minus 5. 4 3 is 12, minus 4 minus 12 minus 16. This is 4 3 is 12, 4 minus 12 minus 8. Okay, now coming to the third row. So here R3 implies, fortunately, here the first element in the first row is given as a 1. So here R3 minus multiply first row elements by 8. So 8 R1. Subtract from R3. So this becomes 0. Now, you see, this is 8 to 16. So 4 minus 16 minus 12. And this is 8 3 is 24, right? So minus lambda minus 24. And this is 8 3 is 24. So 9 plus mu minus 24. You will get mu minus 14. That is 24. So mu minus 15. So first step is over. Now second step. Using this minus 5, that you have to make this as a 0. Well, so this implies, in fact, we need not to write either first row elements or second row elements. So I'll just write only third row elements. So here R3 implies just interchange the elements, multiply. So here that minus 5 into R3, right, plus 12 into R2. Okay. So minus 5 into R3 plus 12 into R2. Of course, here minus of minus. Now you see this becomes 0. Okay. Minus 5 into R3 means it becomes plus 60. And multiply by 12 to the elements of second row, it becomes minus 60. So this becomes 0. Now, here you see, you are multiplying third row elements by minus 5. So here I am writing that minus 5 lambda. Okay. 24 into 5 is 120. And what is 12 into minus 16? So these are the values after simplification. So you can do the simplification. Multiply third row elements by minus 5 and second row elements by 12 and adding together. So we got that. Here you see last row elements are like this. We want that infinitely many solutions. Infinitely many solutions. First, these elements are not at all I'm writing because these are not at all necessary now. So for infinite solutions, you see the concept that this must be 0 and this must be 0. For infinitely many solutions, the last row, entire last row must be 0. So therefore, we get lambda equal to 72 by 5 and mu equal to minus 21 by 5. So option C is correct. If you want only for one unique solution, that this element is not equal to 0. This element is not equal to 0. Then lambda not equal to 72 by 5. We do not bother about. So remember, for infinitely many solutions, the last row elements must be 0. So here, this must be 0. So we get lambda equal to 72 by 5 and mu equal to, you will get minus 21 by 5. Coming to the next question. So here is another question asked in January 2023. We can apply the same procedure. They have given a system of linear equations, has infinitely many solutions. Then what is the quadratic equation having alpha and beta as roots? Right. So anyway, we need to find out alpha and beta. So same as in previous question, here also you write that augmented matrix. Now what is our aim? Our aim is that we have to make these two elements 0 using the first row element, right? So for that, you see that R2 implies R2 minus multiply first row elements by 2 because here we have 2 and subtract from R2. So we have here 0, right? Multiplying by 2 here minus 2, minus of minus plus, so it becomes 4. Now here alpha minus 2 and here multiply by 2, so 8 minus 10 minus 2 over. Now whereas for third row R3 implies that R3 minus 3 times of R1. So it becomes 0. Multiply first row elements by 3 and subtract from the third row. So you will have here 2. This is into 3. 4 minus 3 is 1. And here beta minus 15. So one step over, right? Now second step. Again, this is equivalent to, you need not to write the first row and second row. We'll write only third row elements. So here 0 Now using this element, we have to make this as a 0. So what we have to do is, see, R3 implies, okay, here you multiply 4. So 4 into R3 minus 2 times of R2. Just interchange these two. Multiply like this. 2 multiply to the second row elements. Multiply third row elements by 4. Now subtract. See, this becomes 0. Now here this is 4. Okay. Multiplying second row elements by 2 and subtract from the third row. So you will have minus 2 alpha. Okay. And minus 4. So after simplification, we got that last row elements are, these are the last row elements, that is 8 minus 2 alpha and 4 beta minus 56. Now we want that infinitely many solutions. So for infinitely many solutions, you must know that this becomes 0 and this also becomes 0. Last row elements must be zeros. So therefore, we got for infinite solutions alpha equal to 4 and beta equal to 14. Now you can write a quadratic equation having these two as roots, that x square minus x into sum of the roots plus product of the roots. So this is the correct answer. This you can do. So here is another question. This is asked in June 2022. Now they are asking that system of linear equations has no solution. Previous two problems based on infinite number of solutions now has no solution. Now we apply the same procedure. I have written here that augmented matrix. The point is here, I have taken that middle equation as a first row elements of the matrix because these are all numerical values. So that's why I have taken first row elements as second equation. Now, what we have to do is that we have to make these two elements as zeros. So for that, R2 implies, just interchange 5 into R2 minus 2 into R1. Whereas for third row implies, you see here, we have 3 and we have 5 here. So here, this is 5 into R3 minus 3 into R1. Now, I'll write the elements of second row and third row after simplification. So, these are the elements after simplification. You can calculate it. R2 implies 5R2 minus 2R1. Elements say multiply elements of second row by 5 and elements of first row by 2, subtract from second row. Similarly, multiply elements of third row by 5 and elements of first row by 3 and subtract from third row. So we got these numbers. Now, this is equivalent to, here the numbers are little big. So what I have to do is, I'll just divide the second row elements by 21. So here 0, 1, 5a minus 18 by 21. Okay. And this is minus 11 by 21. So here R2 implies this is R2 by 14. Or you can do directly also. Now third row elements divide by 14. So minus 22 by 14. And this is 5b minus 9 by 14. So here R3 implies R3 by 40. Now it is one step away to get final answer, that R3 minus R2. You just subtract second row from third row. So here you will get 0 and here 0. Okay. So now you need to simplify these three. So after simplification, the third row elements are like this. Now we want that the system will have no solution. So system will have no solution means in the last row, this must be 0 and this is not equal to 0 for no solution. For infinite solutions, entire row must be 0. So this implies after simplification, you will get that a equal to minus 3. Whereas the last one, you see that 5b by 14 minus 9 by 14 plus 11 by 21 is not equal to 0. So after simplification, we got that a equal to minus 3 and this element is not equal to 0. This implies b not equal to, you will get 1 by 3. So here I am writing 1. This is for no solution. So for no solution, a equal to must be minus 3. Okay. And b belongs to R minus set of 1 by 3. Means whatever you take the value for b except 1 by 3. Except 1 by 3. And a must be equal to minus 3. A must be equal to minus 3. So a must be equal to minus 3 means a equal to 3 given in two options B and C. And you see that B not equal to 1 by 3. But here given B equal to 1 by 3. So this is for infinite solutions. So option C is correct. So here is another question based on same concept, but the way of solving this question is different from the previous one. They have used two technical words, that system is inconsistent and consistent. The system is consistent means it must have a solution. It must have a solution means either the system may have a unique solution or infinite number of solutions. Then we can say that the system is consistent. If the system has no solution, then it is said to be inconsistent system. So whenever you see the system is inconsistent, indirectly it means that the system has no solution. So here you see, here in each equation, there is a parameter lambda. In each equation, there is a parameter lambda. When parameter involves in each equation, do not apply the above method. Okay. So here for infinite solutions, for infinite or no solution, Okay, that determinant of A coefficient of matrix must be 0. Okay, so when det A equal to 0, the system may have infinite solutions, or the system may not have a solution at all. So this implies determinant of lambda 1 1 1 lambda 1 1 1 lambda equal to 0. This implies you just expand it, lambda into lambda square minus 1 minus 1 into lambda minus 1 plus 1 into 1 minus lambda equal to 0. This implies it becomes lambda cube. This is minus lambda and minus lambda. So you will have minus 3 lambda. And what is the constant here? This is plus 1, right? Plus 1, which means that this is equal to 2. Okay, so clearly you can verify by trial and error, lambda equal to 1 is a root. Lambda equal to 1 is a root. When you substitute lambda equal to 1, you will get LHS1 is 0, or here you see sum of coefficients is 0. Now, you have to apply synthetic division to find the other factors. So what is that synthetic division? Here, you write the coefficients of given equation. 1, there is no lambda square, 0. Okay. Here minus 3, here 2. Lambda equal to 1 is a root. Here you write 0, adding 1 into 1, 1, and adding 1. You will have, here you write 1 into 1 and minus 2. Here minus 2. Right. So what is the other factor? The other factor is lambda square plus lambda minus 2 equal to 0. So this implies you will have this is lambda plus 2 into lambda minus 1 equal to 0. So lambda equal to either 1 or minus 2. So we got a repeated value for lambda, that is 1. So here we got only 2 values for lambda. Now which one is correct? That the system will not have a solution. Means the system is inconsistent. So here you see for lambda equal to 1. For lambda equal to 1. For lambda equal to 1. That all the equations becomes only single equation. For lambda equal to 1, we get that x plus y plus z equal to 1. Every equation reduces to same equation. So it has infinite solutions. It has infinite solutions. When lambda equal to 1, all 3 equations become single equation. Means all the planes are coincident planes. It has infinite solution. For lambda equal to 2, for lambda equal to 2, right? So the system becomes, you see, that 2x the system has no solution. for lambda equal to 2, Ax equal to B has no solution. Has no solution. So they are asking that what is the sigma of mod lambda square plus mod lambda where lambda belongs to S. So therefore sigma that lambda belongs to S. Here S contains only a single element, that is 2. Mod lambda square plus mod lambda equal to, it has only one element, so therefore 2 square plus 2 equal to 4. Here is another question, that the number of values of alpha for which the system of equations is inconsistent means system has no solution. System has no solution. So for this, that we must have that determinant of coefficient of matrix is 0, 1, 1, 1, because here alpha is involved in many equations. Alpha, here 2 alpha, here 3, and here 1, 3 alpha, and 5. You can use the previous method also, but calculations will be little tedious. So this implies, now this is 10 alpha minus 9 alpha means only alpha. 5 alpha minus 3. 5 alpha minus 3. And this is 3 alpha square minus 2 alpha. 3 alpha square minus 2 alpha equal to 0. So this implies 3 alpha square, and here we have that minus 5 alpha, minus 2 alpha, minus 7 alpha, plus alpha. So minus 6 alpha, and this is plus 3. By cancelling by 3, you will have alpha square minus 2 alpha plus 1 equal to 0. So we got that alpha equal to only one value. But we do not show that for this value the system is inconsistent. Because when det is 0, the system may have infinite number of solutions or no solution at all. So for that, what we have to do is now substitute that alpha equal to 1, or you can use the Cramer's rule. So this is the delta. Okay, so I will use here the Cramer's rule. I will find that delta 1. Delta 1 means replacing the first row, first column elements by the right hand side one. So here 1 minus 1, 4, and here this is 1, 2, 3, and 1, 3, 5. You can use Cramer's rule. So this is equal to, this is 5 minus 9, 10 minus 9, 1, minus 1 into minus 5 minus 12 minus 17 plus 1 into minus 3 minus 8 minus 11. So here the delta 1 not equal to 0. So in Cramer's rule, if delta equal to 0, at least one of delta 1, delta 2, delta 3 is not equal to 0, then the system has no solution. So therefore, the system has no solution. Ax equal to B has no solution for alpha equal to 1. So there is only one and one value for which the given system has no solution. So here is another question asked in January 2023, that S1 and S2 respectively the set of all A belongs to R minus set 0, for which the system of linear equations has unique solution and has infinitely many solutions. So for unique solution, that delta not equal to 0 means determinant of coefficient matrix is not equal to 0. For infinite solutions, either delta equal to 0. In that case, the system may have infinite solutions or no solution. Let us check. So first we'll find that the determinant of coefficient matrix. Here, this is A, 2A, and minus 3A, 2A plus 1, 2A plus 3, here A plus 1, 3A plus 5, A plus 5, and A plus 2. Instead of expanding this determinant directly, just apply simple row transformations, that R2 implies R2 minus 2 times of R1 and R3 minus 3 times of R1. You will get this is equal to A minus, this is plus 2A minus 3A. So here you will have only 1. We are multiplying by 2. So you will have 3 minus A. And this is 1 plus 7A. Here you will have 5. This is 6A. So minus 5A plus 5. 10A plus 2. So after simplification, we got this expression. Now, for unique solution, you see here, this is the quadratic. This quadratic has no real solutions because for this discriminant is negative. Discriminant is negative. Okay. And here given that A is not equal to 0. So therefore, delta is not equal to 0 for all A belongs to R minus set 0. So system will have always unique solution. Therefore, system will have always unique solution. So this is the set 1. Whereas for S2, it is an empty set because the system will have always unique solution for the given values of A.